values. Basically, the question said that you have a part of the paper that you can print on, and then there's a part of the paper that it will not print on, okay? So altogether, it's a paper, but there's a printable area to the paper, which is this dotted area right over here, and then there's the non-printable area that is around the edges of the paper. There are 2-inch margins on the top and the bottom, and 1-inch margins on the side, left and right? So you couldn't print on that, but you could print on everything else. So then what we did is we said, okay, let's define some variables. And you guys, sometimes that can be the most challenging thing because, you know, what are you going to call them? You're going to call them X and Y's, L's and W's, right? So you have to define the variables. So yesterday we started by saying that let's call this dimension L and let's call that dimension W. And then we made the two expressions on the outside as W plus 2 and L plus 4. Are you guys with me on this? Yes or no? We're good? Then we said, okay, so now we have an area of the whole page. The area of the whole page would be the length of the page times the width of the page, so it would be these two expressions multiplied. And the area of the print side of the page would just be L times W, which was given to us in the answer key, in the question that there was going to be 72 for sure. So once you have done that, I have a quick question for you. What if a student started by calling that larger dimension as W and this larger dimension as L? Then what would happen to the expressions on the inside?
So W minus 2 and L minus 2.
Thank you. So you would you stay consistent and you would still get the same exact answer. So there's two different people, they start the problem in two different ways, but they converge to the same answer, which we haven't gotten to, but you guys just need to know that that's also a possibility in case it was in the back of your head. Okay, so once you do that, you can't take a derivative of this yet because it's got two variables and it's not related rates. Okay, it's called optimization. So you can't start with the problem until you don't have one variable on one side and one variable on the other side. This is a problem because we have two right now. So as a class yesterday, we decided we would go ahead and solve for L using LW equals 72. And this is where I left off. I simply substituted the 72 over W into that space. Okay. So what I would like for you to do today is, now that you have an equation, I want you to go ahead and expand it. You can use the product rule if you wish, but I think it's better to expand it and take the derivative of that equation. Set that derivative equal to 0 and find the critical points of that equation. Okay, I will quietly do that on the board and then inshallah we'll talk in a moment. Yes, please. Sure. So this is one of the good reasons to do this is it helps you review old rules, like, you know, expanding rules, the power rule and stuff like that. I know the only thing that tends to bother people at this point is just the fact that there's not y's and x's, right? But it's still the same thing. So do you guys have any questions about my work? Anything about the derivative taking process? One second, could we have used the product rule in it?
Yeah.
Absolutely. If you want to use the product rule, you can. You'd end up having to simplify some things at the end, but you'd be perfectly fine. So, this was which example number?
We counted it back because of the 12 ones.
Yeah, the question asked for what's the area of the paper, so we have to basically put 16 and 8 in that space to find the area. Okay. So each of these are like kind of different in the way that they're set up, right? But the end result is you basically maximizing the dimensions of this paper. All right. I want you to read this. I spoke about this a little bit yesterday to motivate the lesson, but today we're going to actually do the box problem, okay? So I want you to read it. I want you to try to see if you can draw a diagram out of what the question is saying. That part, it's hard to teach it. I will, but I want to see if you can figure out that by yourself. If you don't know where to start with a square, because it says that it's being cut out of a tin sheet that's 12 by 12. So you're making a square, defining some variables as you cut from the edges of this.
How small? They want us to find out how many squares you can make out of that?
No, it's a great question. They're actually trying to figure out how large should each of those squares be that you cut. And the whole purpose is so that you want to have the greatest amount of volume. You want to maximize, yes, you want to cut out just enough so you can make the biggest box with which you've been provided, which is a 12 by 12 sheet, okay? It is a problem we did in pre-calc, so we did the pre-calc version of the problem. This is a calculus version of the same exact problem. It's not easy. Be patient. So what you should do on your paper is you should begin with a square. I did not randomly select these problems. These are really famous problems in calculus that every kid in a really good school will do. Their teacher or the teacher assigns it as like a project. I've even seen some teachers assign this as an actual physical thing. They won't teach them the calculus of it. They'll be like, here's a sheet, make me the box that's gonna have the most volume to it. So you should start off by basically making a sheet, and it's going to be, what are the dimensions of the sheet? Okay, so this dimension here is going to be 12 feet across, and then that dimension there is also going to be 12 feet across. Okay, now let's define some variables, okay? The purpose of this is to eventually bend up the corners after we cut out the edges, and what we end up with is essentially a box, and we want to make it the biggest box possible, so the most amount of volume that you can contain in it. So help me, give me something that I can put on my diagram. You have been taught this before in pre-calc, how to mark up this box problem.
Should we shade
so yeah, that would be the area that we're gonna keep. Those are gonna be the cutout. That's fine. You can shape that, but that's not defining a variable.
Like we'll call them,
It's more like defining the problem. Yes. Okay, can you define them instead of calling them things? Give it some letter, give it something. What do you wanna call it? X? Okay, let's start with X, okay? Question, the stuff that you're cutting out, are these also
so
squares?
it's X by X.
Okay, that's what I'm asking. So you have each of these to be, so you're making the same cut. Okay, all of them are the same cut, alright? Now, next task, I want you to come up with new expressions for this length over here. You remember this, no? And of course, it'll be the same thing, but this length over here.
12 minus 2x.
Okay, beautiful job. So write down 12 minus 2x on this one, and write down 12 minus, space, 12 minus 2x on the other one. Okay. Now goes the folding process. We take all of these and we fold them up. So when we fold them up, on the bottom, you guys will notice that what you essentially have is something that looks like this dimension, which is 12 minus 2x, and then this dimension is also 12 minus 2x. Alright, so that becomes the base of the box. So what would the height of the box be? Right, so now you're folding it up by an amount that's x. So in this box, you're going to go up, basically, by x. Okay. So this is x. Alright, now comes the volume taking process. Okay, what is the equation for the volume of a rectangular prism, you guys? Alright, so the volume of a prism, a rectangular, is length times width times height. Okay, I leave you there. Now go ahead and do what I've taught you. You need to go ahead and create, well, I don't know if this is the one you're going to use, because remember, you need to have only one variable on one side and one variable on the other side. So you have something, an expression that is defined in terms of one variable now. So go ahead, do that, take the derivative, set it equal to 0, and eventually you will come to the conclusion about what x should be. Right? I'm going to quietly do it on the board here, inshallah. Okay, let's go ahead and review the question. Hopefully it's coming together for you now. If you can just make it to the equation, the rest of it is calculus, okay? So the geometry is the hard part. So once you make that equation, here's what it initially reads. If you took a derivative of what stood there, here is the derivative that you guys should end up with. How are you guys doing with that? You're alright?
Yeah.
Okay, now, I needed to solve it equal to 0, so just like finding max and mins. But I noticed that all of these, so I learned this trick now, they almost always have this on the AP exam. Notice how all of these can be divided by 12, so that's actually more convenient to have what you're looking at now. Now, you can't have both of the x's. One of them's gotta go, one of them doesn't make any sense. Do you know which one gets thrown out and which one is a keeper? 6 gets thrown out. Right, if you apply 6 back into the picture, that doesn't make sense. That means don't cut it, right? So, we're gonna go ahead and keep that right there. That maximizes the amount of volume that you would have in this box.
Wait, hold on.
Yes, please.
Like, what wording do you know to use the candidates test? Cause like the first problem we did, we used it, but recently we didn't.
I know, that's the problem. You're kind of learning from here, like, sometimes it's not always written, find the absolute maximum. I guess what you could say is when it says as much as possible, that phrase implies you want the absolute max, okay? Yes? Sure, yes.
So this is how much the squares cosine of 0.3, do you want to find now the area of the squares?
So you can say the squares just need to be 2 by 2. That's it, okay?
Oh, sorry.
Alright, so that was example number 4. This one I will not teach to you, I'm just gonna throw it at you. I feel like this is the type of question where even if you didn't, we weren't taught the lesson, you'd be like, okay, I think I can put this together. So it gives you an equation, and what it's asking for is the minimum product of x squared times y. We're gonna go through the same process that we've learned. I actually got this question off of an AP exam, a bit older AP exam, but this is the question they asked. So initially you'd be like, am I supposed to take a dirt of like the y, or what do you want me to do, right? So again, you guys, we were maximizing the area. What were we trying to maximize over here, you guys?
The volume.
The volume, right? Here, you're not maximizing, you're actually minimizing. So optimization, usually when somebody says optimum, they assume that they're talking about the maximum of it. Here, they're actually wondering about the minimum of it. Okay, so the minimum value, sometimes this might be a cost to a company. They want to minimize cost and they want to maximize profit, right? So this is something that they want to minimize. So when it said the minimum product, so this is the product, this is the equation. I know you're probably accustomed to like a variable before it. You can call it something if you want. You could call it P, right? You could say P is equal to x squared y. And so then this would read dP over dx. And then eventually you would take that and equal it to 0 and solve it. But this number over here, you do need to take it back. You need to plug it back in over there. And that will tell you what the values of x and y would be in order for you to have the minimum amount. So it's not a surprise that for those of you going into maybe something like business in college, that they will have the same exact question, but they have it in what's called business calculus as opposed to engineering calculus. But in business, you want to, like I said, maximize profits and minimize costs. So they teach you the calculus to do that. And the business kids will complain to no end that this is too difficult. But any of you who were to go into business, you would actually find that is one of the easiest problems you've ever done. Yes, question?
Why can't we use x equals zero?
I never thought about that, but yeah, let's take x equals 0 and try it as well. I mean,
-7.
these are both candidates, so try that as well. What would you get in that scenario? So if you plugged in 0, you would get 3 times 0 minus 7.
Oh, that would be,
Wait, it says
They
x
want
is greater
the
than
minimum.
zero. Where x is greater than zero, so you can't.
I didn't even see that, but there you go. Just teach yourself, man.
Well, you could use product rule on your x, so the x squared comes.
Yes, it is.
Could you use the product rule for the x squared?
Yeah,
After it's on 7? And we would do the same as well, or no?
I didn't.
See, oh no, here's the thing.
Just so.
It's a great question. I never ever started taking derivatives till I didn't have everything defined in terms of one variable. If you were to start taking a derivative of x squared y,
No, it's not with the x, it's just like squared slash 7. Like that, and then use the
that
product.
right there,
Yeah.
no, it sure works.
Does it work? Oh, I should probably do it.
No, I took derivative of x squared y.
No, then it wouldn't work because then it's implicit and
What did
you're
you do?
not doing
And
this.
because of the product rule of squared root times 6.
So that was example number 5. Again, let's review here. You start off with a diagram. The diagram is not because you like drawing pictures, but because you need to come up with an equation that combines all of the variables into one variable, and then it's solving it for something else. Of course, the easier kind of problem is if they explicitly tell you the equation, but they rarely do that in optimization problems. So the hardest thing is to make that equation. Once you make that equation, then you need to go ahead and start with the calculus of the equation. But at the end of the day, it's basically an absolute max, absolute min problem applied to a real life scenario, okay?
If it asks for the maximum, then we would use the differences, because I don't think I already use the differences.
If they had said the maximum product of x squared y,
Then we can do the same thing.
because they didn't define endpoints, they didn't say from what to what, they are probably not interested in that. You just think about what a parabola would sort of look like. Its maximum is like endless, and its minimum is a certain point. So think about it like that. That's why they wouldn't ask you that question unless they established a boundary for you to think about the question. Yes? Yeah. Alright, so that was number 5. Now, you're going to be working with a friend on this one. I remember having to do something similar to this myself. And now that you guys have learned the skill of optimization, I will give you 7 minutes, alright? And I will not teach anything of it to you. So now you guys are the engineers, the problem solvers. Read it and draw something out of it and work on the problem. Work with someone.
So there's a square, there's a square, heavy side of the square with glass. Then the height is rectangle, all h. Okay. So the volume, the height of the h as square.
With the base of 3
Square
columns.
base, so it's
Do you
split
understand
this
how I got that?
way. Long case.
Because the base is a square. So it's the base is a square. That's square. Okay, so
Square base.
So
Yeah, we could.
so the final cost is equal to.
Looks something like this.
Yeah, either
Be
we
equal
do
to
Percentage.
the volume of
Yeah.
2 s squared.
0 for the top and bottom.
2 s squared is going to be equal to the top and bottom. 2 s squared is going to be equal to the area to the top and bottom. Times $2. So 2 s squared times 2 plus
There's like
4
2x,
hs.
and then
Times
It'll be two
You guys
wide.
understand? This is the cost of
The
it.
sides are for
It's
$2
two
per square, and
Is
the
that a
bottom is
square?
for the rectangle. Yes, two wide.
And each square base is $2 per square.
Yes.
That goes four side bases. Okay. And each of those side bases is
Oh, why are you doing three?
the side base areas are H times S. And the base areas are
Why
S.
why is it not the same variable? Or, oh, because the cost different?
So we will solve for each.
Oh, the rectangle.
You sure that's the right drawing?
Yeah.
Yeah, 8H is equal to
Okay, so let's do that.
2250 over S squared.
The square root of 2x.
So what you calculate out.
The length is 3.
So cost is gonna be
Subject 2 by 3.
it's gonna be equal to
No,
4.
no, the top, you're talking about the top bottom is 2, yeah.
It's 2 now.
That's very low.
And then the square part is 3.
These two are
12
But inch squared is
12 times
and then
So when you simplify the
so like
equation,
area would
4
equal
squared
2y
is
times
12
3x.
times 2250 plus.
And then we have to solve for one variable and then
I agree with that.
take a derivative and that would be the bottom.
Are we still
Take
taking
the
this?
derivative. So cost is equal to 8S
For dollars
plus
is equal
It says
to
square.
What is the cost?
time
8S.
So you not only have to
divided by
consider
x.
the equation of this
What is
the surface
I think
area.
it's equal to time
There's gonna be two equations, right?
Wait, so I had two equations. I had H squared equal to 2250.
Consider others
Then I
four
had
base
2S squared times 2.
They're all
This is
just
x.
plus
No, it's 2250.
right?
Okay,
And then the
now when
top
you simplify that, you get 4S squared plus 12S
Find the areas manually.
You should use the integral.
multiplied
This is bad. I'm never getting into
12S. And then we're replacing H with 2250 over S squared.
Start off well though.
Two of the
This is
S's
the idea
cross
of
out.
how we're gonna
So it's
find
12 times
So we don't
2250
do
over S.
activities.
So you take the derivative. Then you take the derivative. What is So now DC over DC over DS
It's the brain
equal
trust.
to 8S minus 12.
What do we do with each one of these?
So you take S derivative. Yeah, so you get 12S cross out the S squared.
So the area is x squared, but the volume is This thing is gonna have 6 panels, right? I'm telling you that the panels that go around are gonna be $2 per square. And the ones that are on the top and the bottom are gonna have $3. Or sorry, the other way around, right? And you gotta think about how do you find the area of the top? Okay, now you're in the middle of the surface area right here.
That costs you should, you need to know.
He was only looking at me like
We need to know
he
what
likes pictures.
Okay, by the way, maybe give us the volume. Find the equation that will equal the volume. And then find the x and y variables, and then we'll plug it into the area. Well,
Okay.
Find the area, we can
This is like a brain game.
Let's
You know like the brain game?
No way he puts on the board, we'll figure it out.
I think we just started it at home first.
let's
Yeah.
do is equal
I just
to
need to
Write down the equation,
Literally
write it out.
Literally, like, I thought that's like.
Or no, he just draws the triangle.
He just draws it, I'm like, okay.
He's like,
Now
now
I
all
get it.
pretty. I'm like, alright. Now I got it.
I don't have to fix the grades.
Oh, I don't know.
You got it?
See, I already
Yeah,
got it.
yeah,
Why are you drawing this like this?
It's the same thing.
No, it's not.
Is it clicking yet?
I'm already writing.
15 squared is equal to 220.
I got the surface
So,
area.
That's such a good
I got the
routine.
surface area.
Minus divided by 225 is equal to
You figured it out. I thought I had to block here.
I'm trying to explain it to you. I already finished it.
It's such a good rectangular
Look at my
example.
work. Look at my work.
See? Oh,
I lost
You need a
my
minimum
promise.
six.
I promise.
Oh, you rectangular
That's
prism.
just 15 and it just
So we're gonna, we should think about the 2 and the 4 right now. We're like up to 2 and
Cause they were like, what is the thing?
Yeah, we were right about that, Jenna saying that, you just said.
Say what?
Yo, I don't understand.
Because the first time he wrote yesterday is always
No, hold up, cause our variable is y.
Oh, we did not.
So we use y squared or y squared. That's what I was saying.
Okay, here's
My
the-
head doesn't make sense.
I got this.
I got the same
If you
thing.
have the
Also
first
the same
equation,
See, I'm a smart man.
Oh.
That's right.
alright, let's-
We got the
but
same
if you have
thing.
the first equation, the second equation is
Oh, he's
geometry.
back.
I got
If you have 2 panels on the top and the bottom, their area is gonna be x squared. Now you have 2 of them though, so you gotta put 2x squared. And then you have 4 of the panels on the sides. Now, the question's asking about cost. So you only need to do one little thing to establish
Okay,
the
but us, we multiply 3
solve
by
for one of the
2x squared,
variables,
and you,
like-
no, 2 by 2x squared,
Yeah, he
3
knows,
by
he's
4x
trying to
squared.
get
Good job, okay? So you'll you'll go ahead and take the top and the bottom and you'll multiply that by $2 per square inch, so that'll make 4x squared. And then the ones around are $3 per square inch, so that's gonna be $3. So now this is your cost equation. Let's call it C. 2x squared is gonna get multiplied by $2 per, so it's gonna become 4x squared. And this one is gonna get multiplied by $3 per, so it's total xy. So we're about to take a derivative of that equation. However, once again, look at, I never took a derivative of an
Yeah.
equation until I didn't have one variable. So what are we gonna do? Come on.
I think you should
Y is
solve
equal to
it,
20
solve
50 over x
for
squared.
Solve for one of the variables. And
using
it's
the volume.
it's wiser to solve for y than for x. What's gonna
Square.
you don't want a square root on your number, right? So make that into y equals
You understand?
2,250 over x squared.
Should I go see what it is?
Alright, I'm not doing it for you. Go ahead, do it by yourself.
Okay, now
Alright,
we're
well,
ready to do this.
We have 5 minutes left. Can I only have time to either do it or check your work, right? So you will be able to tell, right?
First, we'll get in and then do the derivative. So it's gonna be 4x squared plus 12.
Yusuf.
Huh?
What's the most positive?
You.
Calculus third junior.
Equals 0.
He's getting married next week.
Yusuf? To who?
You can use a calculator, by the way. It's fine.
What's 12 times 2,000?
That's in front of you, bro.
27,000.
Yes, you.
So 4x
Old
squared is
spice.
27,000
Old spice.
over.
I'm just making sure.
What do you guys like?
27,000.
Like noodles? Olive oil?
And then you take 0.
What deodorant do you use?
And then equals 0.
I didn't say it, he did. I didn't say it.
But they're normal
But
people.
we're also for the extra.
No, but which one do you
Oh,
use?
so
Like,
that's in the.
No, actually,
personality. Like, what do you use?
Like actually,
Yeah,
Hello?
what do you think
You get that?
I feel fun.
This is what you use every man
Did you
gender.
find
What do you use? What do
Yeah.
you use? You have to say something different. It's
What
repeating
is
that.
it?
For the steak, for the steak, I use every man gender. For the spray, I use gender.
That's why I use the green.
What shampoo do you guys use?
Yeah, I'm not gonna explain it, cause like,
Now what's 27,000?
My hair's falling out. Head and shoulders.
3,000.
What do you use?
But that's
medication.
And what's the
I need to put them all. What soap? Dove?
Oh, body soap?
Wait,
Method Men.
how'd you go from the?
What toothpaste you guys
You
use?
know what Method Men is? You guys should use Method Men body wash.
I brought this over.
Colgate? Colgate?
X squared and X
I was looking at my glasses on. I didn't even know who was
I
talking
usually
to me.
use
I
Colgate.
saw it. I thought I was
The
like,
one that I tried the more deodorant. Sensodyne, you know Sensodyne?
What color is your toothbrush?
this is not that hard to get into.
Top and bottom.
Getting into is not that hard, it's just.
This is
This was
interesting.
the top and bottom.
yeah, it's. I remember I keep going
What's your
from
dream car?
Area
just
of
super
the bottom
expensive,
and the
that's the
top
problem.
is X squared.
You know, Justin Tim's probably asking, you come to.
And there's 2 squares. The rectangle.
You said according to that.
So top and bottom, this is solid. This
Not as a doctor, you're not.
There,
Not as a doctor.
Okay, first.
And that was X, Y. And then
GC3RS is like 250.
You looked at me.
It's not bad. I live in it.
Bro, I kind of saw this.
Okay, here
Hella
goes
interesting.
the box. I'm so happy today because Yusuf said he's finally interested in something I've done this year. So.
Wow. Great.
Another round of applause.
Great.
Yeah, I don't know. I'm glad I got across the somebody.
Use the bathroom now.
Yeah, I think I challenged him. So, guys, for this, the homework is basically 5 questions. Most of them are rectangle questions. It won't take you too long. Bring them in tomorrow. Guys. And then we'll start doing our review for the last. You get the same answer?
Yeah, this is so much more interesting than like.
It is. You know, that's why I actually haven't taught this lesson in 10 years, but I felt like your class was taking to it.
We actually like use.
Bro, why? What's that our class? I can't do like this much.
We're lost.
Maybe it's called like